This is lab 6.4 Excel, and in this lab we have a company, Heartwood Cabinets, that has a joint production process that creates several joint products, and we need to determine how to allocate these joint costs to the products using various methods. Let's take a look at our data. That's lab 6.4 data. And we see that we have $500,000 of joint costs. We have 4 joint products. These are different grades of lumber. FAS is first and second, so that's the best grade of lumber. We've got Select, number 1 common, and number 2 common. Now, Heartwood Cabinets produces 100,000 board feet of lumber every day. And here we can see how much we can sell each of these products by the board foot. We can also see separable cost per unit. That's the additional cost associated with each of these products should the products be processed further beyond the cutoff point of our joint production process. And if these units are processed further, we have in column F the amount of revenue that we can get per board foot for each of the joint products. And we're going to see that the method we use to allocate these joint costs can really change the reported profitability of each product. So it's really important that we understand our costs so that we can make good strategic decisions. So the first method we're going to run through is called the physical units method. It's the simplest method, and the cost allocation is based on prorated units at the split-off point, which we can find in column C. So at the split-off point, we have 12,500 board feet of first and seconds, and so on to get to 100,000 total board feet of lumber. And to determine the total cost under the physical units method, we're going to take our total allocation amount, lock that, divided by our total board feet, which will give us the cost per board foot, and we're just going to multiply that by the number of board feet we have for each of our joint products. And we'll just copy that down. And if we sum these amounts together, we should get $500,000 so that all of our joint costs are accounted for and allocated to one of our 4 joint products. The second method we are going to use is the sales value at split-off method. Now this method is very similar to the physical units method. The difference is that the allocations are based on sales value at split-off rather than the production quantity. So that's the total revenue that we could get at the split-off point instead of the total number of board feet. So in cell G2, we're going to enter sales value at split-off, and then we're going to calculate the sales value at split-off by multiplying the quantity of board feet for each product times the as-is selling price, or the price at the split-off point. So let's copy that down and make this an accounting number so it's in dollars. And then let's total the revenue we can get at the split-off point. We should get $877,500. So to figure out the allocation of these joint costs, we're going to divide our total cost by our value at split-off and multiply by each product's sales value at split-off. So for first and seconds, that's going to be G3. We're going to copy this formula down, and we'll copy our total over as well to make sure that we've got $500,000 of costs allocated. And we can see that it's very different. The results are very different from the physical units allocation. Now, the third method we're going to look at today is the net realizable value method. It's mechanically similar to our previous methods, but the allocations are based on net realizable value, which is calculated as the final sales price minus the separable costs. Well, you might ask, how are we going to know if Heartwood is going to sell this lumber as is at the split-off point, or if they're going to process the wood further and make cabinets? Well, we're going to make a pretty safe assumption here and say that Heartwood is going to maximize profit. If they can make more money selling cabinets than cut lumber, then Heartwood will do so. So in cell H2, we're going to enter processing decision, and we're going to use the if function in Excel to indicate whether or not the products should be processed further or sold as is. And the formula is, we'll use the if function here, if the final selling price, that is the price after they process the wood into cabinets, minus the separable cost, is greater than the sales value at split-off, then Heartwood will process these units further. If not, they'll simply sell it as is. Okay, let's copy that formula down. Give ourselves some more room here. So it looks like Heartwood will process our first 3 joint products further, but will sell 2C as is. Now let's label I2 net realizable value. Make this a little bigger. Okay. So the net realizable value for first and seconds is going to be equal to the sales price after processing these units further minus our separable cost per unit times the quantity of board feet that we have. And that's going to be the same for the first 3 products. Let's make all of these an accounting number. There we go. For 2C, which we're not going to process further, we're going to set cell I6 equal to G6. And then we want to sum up this column. Now let's figure out our allocation amount. We're going to take the allocation amount divided by the net realizable value. We're going to multiply that by the net realizable value of each product. Copy this down. Let's also copy D16 to E16 to make sure that all of our costs has been allocated. And it has. That looks good. And so now we can move on to our last method. That's the constant gross margin method. It's calculated very differently from the other 3 methods. The constant gross margin method assumes that all joint products have an identical gross margin, which we calculate by dividing gross profit by revenue. So the first thing we have to do is determine the company-wide gross margin. And just like before, we're going to assume that the choice to process units further is contingent on whether Heartwood can make more money. So the total revenue that we're going to get from first and seconds is the board feet times the processed further price or revenue per unit. And that's going to be the same for the next 2 products. For 2C, it's going to be the board feet times the as-is selling price. And let's make these an accounting format. And we're going to sum up our total revenue. And we get $1,577,500. Now let's calculate our separable cost. That's going to be equal to our board feet times our separable cost per board foot or unit. Now remember it's 0 for 2C because there is no additional processing. And we're going to copy the sum function over from B24 to D24. Let's go ahead and make all of these numbers an accounting number. There we go. Now we're going to fill out row 24. Our total joint costs are equal to A12. Our gross profit is equal to our revenue minus our separable costs minus our joint costs. And our gross margin is equal to our gross profit divided by our revenue. And we're going to make this column a percent. So 29.48% is our gross margin. So under the constant gross margin method, we need to ensure that each product has a gross margin of 29.48%. So let's go ahead and use a formula to do that. So F20 is going to be equal to F24. We're going to lock that formula so that it's all the same all the way down. And then what we can do is back into the amount of profit we need in order to make sure that our gross margin is 29.48%. And we're going to do that by multiplying our revenue times our gross margin. And push enter. And we can copy that down through row 23. And finally, we're at the point where we can allocate our joint costs. We have $500,000 of joint costs. We're going to spread this out among our 4 joint products. But this is all a plug figure. It's what do we need to put into joint costs to make sure that we have the correct gross profit and then a constant gross margin. So we know that revenue minus separable costs minus joint costs equals gross profit. We can rearrange this formula to come up with what we're going to put in this cell, which is revenue minus our separable costs minus our gross profit equals our joint costs. And we'll copy this down. And then back up in row 12, we're going to reference the new joint cost we've just calculated so that we have it all in one little table. And copy our sum formula over, and there you have it. Take a look at how different these cost allocations are based on what method we use. These differences are big enough that a product's profitability or loss may be determined entirely by what method we use, even though the total cost for the company hasn't changed. And so the method we use really affects both strategy and how our employees within the company operate. Let's go ahead and make this all accounting. All right, one last step in this lab. The lab materials mentioned that Heartwood's production process creates sawdust as a byproduct, which Heartwood uses to produce fuel pellets. Now these pellets cut down on waste and generate $1,400 per day in profit. Let's assume that Heartwood accounts for this profit by simply reducing the allocation amount from $500,000 to $500,000 minus the $1,400 in profit generated by these pellets. Now, because we've set up this nice template, we can immediately see how all of our cost allocations change under each method. So setting this up in Excel is a very useful exercise because it allows us to do some sensitivity analysis and what-if analysis much more quickly than if we were doing this by hand. And this concludes Lab 6.4.